Hello and welcome to Trend in Research, where we dive into the latest breakthroughs shaping our understanding of the world. Today, we spotlight a transformative piece of research titled BERT, Pre-Training of Deep Bidirectional Transformers for Language Understanding. This study revolutionizes how we approach language models by leveraging deep, unsupervised pre-training, significantly enhancing performance across a variety of natural language processing tasks. Prepare to explore how this method not only tackles the limitations of previous models, but also sets new benchmarks in language understanding. Let's delve into the insights and implications of this groundbreaking work. In addressing the limitations of unidirectional models in natural language processing, our research introduces a novel bidirectional architecture. This approach significantly enhances language understanding, particularly in scenarios where resources are limited. By leveraging a bidirectional model, we can capture a more comprehensive context, improving performance across a variety of tasks. Turning to prior works, it's important to note that initial models, such as OpenAI GPT, primarily utilized unidirectional pre-training. This method restricts the flow of information to one direction, either forward or backward, which inherently limits the model's ability to fully understand the context of the language. Our paper contrasts these traditional approaches by implementing a bidirectional strategy, allowing for a richer, more nuanced understanding of language, which is crucial for tasks requiring a deep comprehension of context. Let's delve into the core of our discussion today, focusing on BERT, or Bidirectional Encoder Representations from Transformers. BERT revolutionizes the understanding of language by employing a masked language model for pre-training. This innovative approach allows the model to integrate context from both the preceding and following text, significantly enhancing its language comprehension capabilities. Now, turning to the key contributions of BERT, it's important to highlight how it advances the state-of-the-art in natural language processing. By leveraging deep bidirectional pre-training, BERT not only sets new benchmarks across a wide array of NLP tasks, but also reduces the reliance on heavily engineered, task-specific architectures. This demonstrates the profound effectiveness of bidirectional pre-training in improving language models. Through these advancements, BERT has significantly pushed forward the boundaries of what's possible in natural language processing. Let's delve into some of the significant results achieved through this research. Our evaluation on the GLUE benchmark, a comprehensive suite of natural language understanding tasks, shows that our model outperforms existing models on several sentence-level tasks. This achievement highlights the importance of deep, bidirectional pre-training in enhancing model performance across diverse linguistic challenges. These results not only demonstrate the robustness of our approach, but also set a new standard in the field of natural language processing. Let's delve into the transformative architecture of BERT, which stands out by employing a bidirectional approach, a significant leap from previous models. As illustrated in this figure, BERT's architecture contrasts sharply with the unidirectional and concatenated models used in earlier language models. This bidirectional capability allows BERT to integrate context from both the left and the right side of a token, overcoming the limitations posed by unidirectional models. Furthermore, the effectiveness of language model pre-training cannot be overstated. It is proven to significantly enhance the performance of various natural language processing tasks. By pre-training on a large corpus and then fine-tuning on task-specific data, models like BERT achieve remarkable state-of-the-art results across a broad spectrum of NLP challenges. This method not only improves model performance, but also reduces the need for complex, task-specific architectures. As we delve deeper into the realm of language models, it's crucial to address the inherent limitations of traditional unidirectional models. These models, while foundational, pose significant constraints when learning numerous parameters from scratch. This inefficiency becomes particularly evident in tasks that require a nuanced understanding of context from both preceding and succeeding text. This brings us to the motivation behind our study. In the landscape of natural language processing, the ability to efficiently handle both sentence-level and token-level tasks is not just beneficial but necessary. The constraints of unidirectional context, where each token can only attend to previous tokens, limit the model's ability to fully leverage the available textual information. Specifically, these limitations become stark in complex tasks such as question answering, where understanding the full scope of a query's context is paramount. This is why addressing these challenges is not just an academic exercise, but a crucial step towards building more robust and capable language models. Understanding and capturing full contextual information is especially critical in scenarios where resources are limited, and every bit of contextual insight is needed to make accurate predictions or generate coherent text. This underscores the importance of our problem and sets the stage for the solutions we have developed in our research. As we delve into the realm of language model pre-training, it's crucial to acknowledge the limitations of previous models, such as OpenAI GPT and ELMO. These models predominantly utilized unidirectional architectures, which inherently restrict the flow of information to one direction. This limitation poses significant challenges, particularly in comprehending the full context of the input data, which is essential for tasks that require a holistic understanding of the text. To address these challenges, we introduce BERT, Bidirectional Encoder Representations from Transformers. BERT revolutionizes the standard approach by employing a bidirectional architecture. This allows the model to integrate context from both directions, providing a richer understanding of the language structure. Furthermore, BERT incorporates a novel training strategy known as the masked language model. This technique involves randomly masking words in the text and training the model to predict these masked words based solely on their context. This approach not only helps in learning deep bidirectional representations, but also significantly enhances the model's ability to generalize across different language understanding tasks. Through these innovations, BERT sets a new standard in the field, demonstrating remarkable improvements over previous models. Let's delve into the core of our discussion today, the introduction of BERT, or Bidirectional Encoder Representations from Transformers. BERT revolutionizes the understanding of language by leveraging bidirectional context, which is crucial for comprehending the full meaning of sentences. This bidirectional approach allows the model to interpret information from both the left and the right context of a token simultaneously. The motivation behind BERT stems from the limitations observed in unidirectional models. Traditional language models, which process text in a single direction, either from left to right or right to left, often miss the context provided by the other side. This can lead to suboptimal understanding and performance, especially in complex language tasks. BERT addresses this by employing a deep bidirectional architecture, significantly enhancing performance across a wide array of natural language processing tasks. This innovative approach not only improves model understanding, but also sets a new standard in the field. Let's delve into the core components and the training process of BERT, which stands for Bidirectional Encoder Representations from Transformers. BERT fundamentally operates on two innovative pre-training tasks. The first is the Masked Language Model, or MLM. In this model, some tokens in the text are randomly masked, and the goal is to predict their original vocabulary ID using only their surrounding context. This approach allows the model to learn a deep understanding of language context from both directions. The second task is Next Sentence Prediction, or NSP. Here, the model learns to predict whether two segments of text naturally follow each other in a document. This is crucial for tasks that require an understanding of the relationship between sentences, such as question answering and natural language inference. Moving on to the training process, BERT is first pre-trained on a large corpus of unlabeled text using these two tasks. This pre-training helps the model learn a rich representation of language. After this, BERT is fine-tuned on specific downstream tasks. This involves making minor adjustments to the pre-trained parameters to suit particular applications, significantly reducing the need for task-specific model architectures. This dual approach of pre-training, followed by fine-tuning, allows BERT to achieve state-of-the-art results on a wide array of language processing tasks, setting new benchmarks for the field. Let's delve into the technical innovations and experimental design of BERT, which stands out due to its unique approach in handling language representations. BERT utilizes the transformer architecture, which is pivotal for its ability to weigh the importance of different words in a sentence, regardless of their positional distances. This is achieved through self-attention mechanisms. A significant breakthrough in BERT is its bidirectionality, enabled by the Masked Language Model, MLM. This approach allows the model to learn context from both directions, which is a departure from traditional unidirectional training methods. Moving on to the experimental design, BERT was pre-trained and fine-tuned using diverse datasets, ensuring robustness and versatility. The model's performance was rigorously evaluated using benchmarks such as the GLUE score, which assesses capabilities across various linguistic tasks. In terms of algorithmic steps, BERT's training involves two main objectives, the MLM and the next sentence prediction, NSP. These training objectives are crucial for the model to effectively understand language context and relationships. The fine-tuning process then adapts BERT to specific NLP tasks, leveraging its pre-trained parameters to achieve state-of-the-art results across different challenges in the field. This innovative approach not only enhances the model's performance, but also simplifies the need for complex, task-specific architectures in NLP applications. Let's delve into some specific examples and demonstrations from our research on BERT. We'll explore how BERT processes input and output for various tasks. For instance, in named entity recognition, BERT effectively uses its bidirectional capabilities to understand context from both preceding and following tokens, enhancing its prediction accuracy for each entity in a sentence. Additionally, let's look at how BERT utilizes context in its Masked Language Model, MLM, approach. By randomly masking words in a sentence and predicting them based solely on their context, BERT learns a robust representation of language that is not biased towards the sequence of the text. Moving on to improvements over previous models, BERT's bidirectional nature is a significant enhancement over unidirectional models like OpenAI GPT. This architecture allows BERT to outperform in both sentence-level tasks, such as sentiment analysis, and token-level tasks, such as question answering. This is because BERT can integrate contextual information from both directions, leading to a deeper understanding of the language structure and subsequently better performance on a wide array of NLP tasks. Let's delve into the technical results of our study, illustrated here with an overview of BERT's pre-training and fine-tuning processes. This figure captures the uniform architecture we employed across different tasks and how we adapt pre-trained parameters for specific NLP tasks. In evaluating BERT, we utilized a range of benchmarks and metrics designed to assess performance across various natural language processing tasks. Our results demonstrate that BERT not only adapts well across different tasks, but also sets new standards in model performance, significantly outperforming existing systems. This is a testament to the robustness and versatility of the architecture. Turning our focus to the technical results, our model has set new benchmarks on the GLU tasks, outperforming previous models such as OpenAI GPT and ELMO. Particularly, it shows remarkable performance in sentence-level tasks, like natural language inference and paraphrasing. This demonstrates the model's ability to understand and generate nuanced interpretations of complex sentence structures. Additionally, our ablation study sheds light on the significant impact of the bidirectional architecture and the depth of the model. By systematically varying components of our model, we've been able to pinpoint how each contributes to its overall effectiveness. These insights confirm the critical role of unsupervised pre-training and bidirectional processing in achieving high performance across diverse NLP tasks. This study not only reinforces the importance of architectural choices, but also guides future developments in language model pre-training. As we conclude our discussion on the transformative impact of BERT, let's recap the key contributions that this research has brought to the field of natural language processing. Firstly, we introduced a deep bidirectional architecture for language model pre-training, which marks a significant departure from previous unidirectional models. This bidirectional approach allows for a more nuanced understanding of language context, enhancing the model's ability to interpret text. Secondly, our findings underscore the effectiveness of unsupervised pre-training. By leveraging vast amounts of unlabeled data, BERT significantly improves the performance of language understanding systems, even in low-resource settings. Lastly, the application of our bidirectional model has set new benchmarks across a broad spectrum of NLP tasks. From sentence-level tasks like natural language inference to token-level challenges such as named entity recognition, BERT has consistently achieved state-of-the-art results, pushing the boundaries of what's possible in natural language processing. These contributions collectively advance our understanding and capabilities in the field, opening up new avenues for research and application.